Good morning, good afternoon, or good evening. On behalf of the Independent Evaluation Group, let me offer a very warm welcome to everyone as we kick off the second week of COP30 and the Evidence for Climate Action Pavilion and Program. As you might know, E4CA is a global platform for sharing the latest evidence on climate action at the occasion of the COP. It draws partners from a wide range of evaluation functions that are united by a shared commitment to advancing climate action based really on rigorous evaluations and evidence. IEG is a leading partner in the program that has been offered since last Monday. It has brought together a rich tapestry of sessions and voices from government leaders, researchers, as well as indigenous communities and global institutions. I am Estelle Raimondo, I'm the head of methods in IEG, and I'm delighted to introduce to you our presenter, Virginia Ziulu, who is a data scientist in IEG's methods advisory function. Welcome, Virginia. She specializes in the application of remote sensing and computer vision methodologies for geospatial analysis. Her expertise spans a wide range of techniques from machine learning to deep learning, generative AI, what we will call geo-AI, explainable AI, and photogrammetry. And since 2022, we've been very lucky to have her lead the integration of imagery data into geospatial analysis to enhance evaluations in IEG. Today, Virginia will share with us some examples of how we have used geospatial analysis in our work and specifically for climate and biodiversity related studies. I would warmly invite all participants to the event to post questions, comments, remarks as we go through directly in the chat function, which we will monitor. I thank you very much for being here. I will now pivot to the presentation and let Virginia share with you all of her experience and wisdom. See the screen?
Yes, yeah. I can see it. If you could go to the next slide, please.
Sure.
So I wanted to start this presentation by motivating this discussion by briefly mention some of the reasons why I think geospatial analysis is an important methodology in the context of climate action. First, geospatial analysis help us reveal climate change on the ground. And by this, I mean that with geospatial analysis, we can identify, for example, hotspots of deforestation, flooding, heat waves, emissions, and so forth, showing where interventions are mostly needed. Second, geospatial analysis can help link interventions to place. So, for example, by connecting adaptation and mitigation strategies to local environmental, demographical, and infrastructure context. Third, it can help us enhance decision accuracy by providing objective, location-based evidence that complements other data sources such as surveys, climate models, and administrative data. Four, it can help us change change over time by monitoring from a temporal perspective, land use shift, urban expansion, or carbon stocks to better assess policy effectiveness. And finally, it can help us integrate diverse data sets for more nuanced insights. And that's where I think is one of the key strengths of this methodology. So in conclusion, for this slide, the main point I wanted to emphasize here is that geospatial analysis is also increasingly accessible given the rich wealth of publicly available data sources, as well as the increase in computational resources. And all of these combined has made it a method that's increasingly accessible within a variety of contexts. and that can provide very rich and nuanced insights in the context of climate action. Next slide, please. So as Estelle mentioned before, so I work as part of the independent evaluation group. So in this context, so we applied a geospatial analysis for the purpose of evaluations. And the way we think about the different categories of applications in our evaluations is these three that you can see on the slide. So essentially for measurement, which refers to more descriptive analysis to see patterns across space and across time. For relevance, which refers to the appropriateness of project objectives and measures the extent to which efforts fit with the local needs and the strategies of targeted communities. And finally, for effectiveness, which allows us to understand the extent to which the expected specific goals have been reached through the project activities and effort. So to make this discussion a bit more concrete, on the next few slides, I will show you some specific examples of our recent evaluations. And I chose examples that are specific to climate action so that you can see how we specifically apply different data sources and different techniques. So the first example that you can see now on the slide refers to a recent global evaluation on biodiversity, where we aim to quantify land cover change in protected areas. So as I mentioned, this was a global evaluation, so we were focusing both on terrestrial and hybrid protected areas all over the world, and during a 10-year period throughout a large number of projects supported by the World Bank. And in this case, so we use as primary data source Dynamic World, which is a publicly available and AI-generated data sets that provides very granular land cover classes, so specifically 9 different classes, and at the very granular spatial level, which is 10 meters resolution. And our focus for this approach, what we were looking specifically at 526 protected areas located in different continents. And we were trying to understand the change in tree cover, which is one of the specific types of land cover that were included on these data sets, and any transitions between natural classes to human-generated classes, such as, for example, agriculture and build-up. So the focus of the analysis was quantifying change to identify areas where land cover transformation may signal risk to biodiversity or require further investigation. So on the maps you see on the slide, that's just an example of one of these 526 protected areas. But the analysis that we did was summarizing the patterns that we saw globally for all the areas of our analysis. But the maps can give you a sense of the detail that this type of data sources can provide. Next slide, please. The second example I wanted to share with you was part of country-specific evaluation in Tanzania. And the angle that we were interested in is flood resiliency. In a way, this is a very different type of analysis than the one you saw previously. The previous one was global. We were interested to see the bigger patterns that we can detect in this large number of protected areas. This was a very targeted application. So the area that you can see on the map is the bus rapid transit system in Dar es Salaam in Tanzania. And so you see that in black on the 3 illustrations on the slide, and we just simply drew a bounding box that comprises the areas around this route. And in this particular case, what we knew that the area had seriously flooded after the route was built. So what we were trying to understand is whether with data available at the time of the project design, if this could have been known. By this, I mean the risk of flooding of that particular area. And so we use two different data sources to analyze this. The first one was a digital elevation model, which is the first of the three maps that you can see on the slide. And that shows the height of the land. And the intuition here is that lower areas tend to flood more because the water cannot flow correctly. The second data source that we use is surface imperviousness data. And this refers to how hard is the surface on the area. And again, a harder surface such as asphalt or buildings don't absorb rainwater and also increase the likelihood of flooding. And the third map that you see on the slide is a combination of the two data sources I mentioned before and shows those areas that have harder surface area as well as low elevation, meaning an increased risk of flooding. And what you can see on the illustration is that there is a strong overlap between the areas that we identify as high flooding probability and those that where the part of the BRT actually was built. So the next example that I wanted to show is was focused on mapping mangrove cover change in coastal areas. This was also part of a global evaluation focused on blue economy. This was an application that we did for a case study focused in Belize. So unlike the biodiversity application that we saw earlier that was focusing on terrestrial protected areas, here we were focusing on marine and coastal protected areas. And we were trying to understand the change in the mangroves population across these areas. In order to do this, we use an existing global data set that maps mangroves population, which is derived from radar data. And we looked at this data for three periods, 2010, 2015, and 2020. And then we used a change detection algorithm to be able to see what was the change between 2010, 2015, and 2015, 2020. So you can see here on the slide an example of one of these areas in Belize. And so you can see in green showing the areas where there has been a gain in mangrove cover in the sub-period. And in red, you can see the areas where there has been a mangrove loss. And here also the message is how useful this could be, not only to see the temporal changes, but also to identify precise areas that might require further investigation. Next slide, please. And to conclude this presentation, I just wanted to summarize with some key messages. The first one is how publicly available data can go a long way. All the examples that I showed before were produced exclusively using publicly available data sources and computational resources. So the message I wanted to emphasize is that even freely available resources can uncover details of great precision, both from a temporal and a spatial perspective, that can really illustrate and bring to reality patterns of environmental change. The second message I wanted to leave you with is that geospatial analysis can help bridge science and policy by turning Earth observation insights and data into nuanced messages that can inform information, mitigation, and resilience. And finally, I wanted to also emphasize how spatial evidence strengthens climate accountability by revealing where change is happening, who is affected, and whether actions deliver results. So I hope this presentation has been useful and interesting, and I'll leave you with this, and I'm happy to answer any questions.
Thank you very much, Virginia. That was a set of really useful examples that also show the variety of things that can be captured through Earth observations and through the different techniques that you're an expert in. So I'm going to stop sharing the screen and we're going to move to a more interactive phase. I invite all of you to really post your questions in the chat or your remarks, or maybe if you have yourself worked with geospatial analysis before, sharing some experience would also be more than welcome. And in the meantime, I'll kick off with the first question. So, Virginia, even with the vast amount of images and the very serious improvements in computational power, in techniques, etc., I imagine that there are some challenges that we are facing in kind of bridging that science and action place, especially when it comes to climate and biodiversity. So I would like for you to reflect a little bit on those challenges and where do you see progress taking place?
Yeah, thank you for the question. And indeed, there are many challenges when starting to plan these applications. The first one I would say in terms of identifying the right data sources for the analysis, because the analysis itself is of course driven by the evaluation question and what it is that what type of insights we're trying to derive. And that normally means that there are certain constraints and what type of data could be useful. And by that, I mean, we need the right spatial resolution, which could be very different for a global evaluation than for a very specific targeted application, as the flood case in Tanzania that we saw, but also the temporal aspect, because there tends to be a trade-off between spatial and temporal resolution in terms of what's available. So we normally try to obtain at the very least 2 data points in time in order to be able to make a comparison of before and after project implementation, or even in some periods in between. So that initial stage of trying to see what's available in terms of data sources and selecting those that match the requirements of the analysis in order to answer the evaluation question, that can be a challenge. And the second one that I wanted to mention is on the validation stage. And I think that's absolutely critical in all methods, but especially when talking about geospatial data sources. There's always specific realities that are driven by either geographic or even cultural conditions on the ground. And imagery data can provide a quite objective overview of many spatial changes. However, these need to be understood in context, and they need to be validated, especially when on the modeling stage, with observations on the ground. So specifically what I'm referring to, if we're doing a model, for example, for classification of different land cover, this can be validated in different ways. So it could be done, for example, using high resolution satellite image. It could be doing inspections on the ground to try to see if we can verify the same patterns. It could be done through literature review if there are other studies that cover the same area. But I think that's absolutely critical in order to bring trust into the conclusions.
Thank you, and you're touching on very important points that we have questions about. So maybe you can elaborate a little bit more on this issue of what we call ground truthing, right, in some shape or form. So we have Carrie, who is interested in you elaborating a little bit more about the types of public data sources that you have been able to leverage and the potential limitations there. And I will bring also a question that's related by Andre, who is interested specifically on the AI generated data. You mentioned in your presentation that you were using a combination of both. And so what, if any additional, checks and verification you need to do in order to be able to combine those two kinds of data sets?
Yes, so in terms of publicly available data sources, so there's quite a large variety of them, I would say. Talking mostly about imagery data, on the first level, I would say it's the publicly available data from space agencies, such as the European Space Agency or NASA, for example, that they make available a large percentage of the images captured by their satellites or some of the radar data as well. The only caveat is the spatial resolution, that it tends to be good for let's say country level analysis for sure, global analysis, but if you're looking at a very specific area, that might not be sufficient depending on the application. But it's still a quite robust data source, and it has a high temporal resolution as well. So it's a very good first start. Then I think Google Earth Engine has a lot of data sources that are publicly available through their own repositories. So that's another place to look for that. And lately, there has been a lot of AI-generated data sets that have been made available. And that, in a way, brings me back to the second part of the question in terms of the specific case with biodiversity. And that's an excellent point. And the validation, I think it's absolutely critical, as I was mentioning earlier. I think that this can be done at different levels. The first one is looking very clearly at the documentation of the data set itself, which provides a lot of the assumptions and the limitations that the data set has. And there's normally a paper associated with the data set that provides all these different clarifications. Then I think it's important to keep in mind the potential sources of error. So the dynamic world in particular is a probabilistic model. It has several assumptions about the classification and specific classes where it tends to have a higher error rate than others. So that's important to keep in mind when looking at the results. And there's also been a lot of third-party validations that have been published through different peer-reviewed journal articles that have tested, for example, the quality of the predictions across different continents, for example, to try to understand, is it working better in one case over the other? So I think these are all important things to keep in mind before doing the analysis in order to design the best way to process the data as well as to understand the result. And after the analysis, there are still some more things that can be done. For example, talking to experts on the particular subject matter or on the specific conditions on the ground for specific area, for example, as well as looking at high-resolution satellite imagery that is typically publicly available for viewing, not for downloading. But in that case, you can still corroborate whether what you were able to extract from these data sources matches the reality in the ground.
And when you can, also, combining that with field visits, which we have done in several of our case study work, and that was a question that we also had from Puspita. So absolutely, as much as possible, actual ground verification, talking to stakeholders who are there is very important. But when it's not possible, this thorough checklist that you just listed is critical. Let me pivot a little bit more on the use side. So we have a first question, which is more around so combining basically geospatial analysis with typical evaluation analysis, which is how do you differentiate in some ways between what's the operation, what the project has done versus what has been an evolving condition in context. So more specifically regarding the BRT example, how do you differentiate between the resilience effectiveness part or lack of effectiveness, and then just exposure or perhaps increased exposure to risks such as flooding? How do we do that? Before after might not be the most compelling way of doing this. Is there more ways of combining evaluation techniques with geospatial analysis that could be better?
Mm-hmm. Mm-hmm. Yes, I think there are different ways, and we have taken different approaches on different evaluations depending on the question itself, of course, but also the data availability and how far we could get into the analysis. So the simplest one is the before and after, as you were saying, that it might not give you a sense of the specific attribution to the project, but at the very least, it does provide some objective understanding of the pattern of change. In some other cases, we have been able to go a bit further than that. And for example, by using counterfactuals or using more econometrics models, such as difference in differences. So that can give us get us more away from the purely descriptive analysis and moving either towards attribution or contribution, depending on whether the assumptions are met. So an example of that, so that it's not one of the evaluations we showed on this slide. So we actually combined nighttime light data, which is also a type of satellite imagery, with survey data into a diff in diff model in order to understand patterns in energy access. And that's an example on a framework where this could work and could lead to very interesting insights.
Okay. And so to close, because we only have a couple of minutes left, I will leave you with just one last question, which is about how these kinds of analysis and the findings are received typically by evaluation users, by people working in government. This visual aspect, do you find that it has a compelling effect? And have you seen any partnership or community of practices that are being developed in trying to strengthening the relevance of geospatial analysis for evidence for action?
Yes, I think as you mentioned, the visual aspect of it can be quite powerful, especially being able to see on a map or a chart that can summarize quite complex and nuanced information into a clearly understandable image. I think that can be quite powerful, both for other evaluation colleagues or government counterparts and other external stakeholders. So I think that's one advantage of this methodology, that it can involve quite complex processing and workflows with many steps, but the findings can be summarized in a clear map that can show the conclusions. Of course, it's have a lot of assumptions as well, but it can tell a clear story. And there are indeed many different communities and groups that are focusing on this type of applications. So the one that I wanted to mention is there is the MapMe initiative that is focusing on the development of different open source tools, methodologies, and approaches focused specifically for monitoring and evaluation in the context of international development cooperation. And on that, well, we have contributed. So there's a the book that's upcoming next week, where we have contributed some chapters detailing some of the more details, some of all the assumptions, limitations, and so forth of working with geospatial analysis for evaluation. There is also a World Bank internal geospatial community that's starting to take shape and to grow, as well as UNDP led community of practice, also focused on the geospatial analysis for evaluation.
Great. So as with everything, partnership is really essential. And so I really want to thank you for this presentation, as well as all the participants and their questions. We were not able to get to all of them, but hopefully you got a glimpse of that and you can find further resources in the chat that we posted. I invite you to consult also the E4CA program, the pavilion in Belém, and to discover, among other things, all fresh evidence on biodiversity, on forests, on oceans, on nature-based solutions, and so on and so forth, and to really try to have a community that's pursuing this evidence for action. So thank you very much, and we will say goodbye for now.
Thank you.